Hello students. So now we will solve the numerical which we have seen. We have seen in previous session the design procedure. Now we'll try to solve the numerical on this. So first of all, as I told you in design procedure, we'll have to read a numerical correctly, carefully, and then write down the given data. That would be your first prior step. Correct? So I'll read. A line shaft transmit 25 kilowatt power. So I'll write given data, that is P is equal to 25 kilowatt. It is 25 to 10 raised to 3, it will be in watt, at 200 RPM 200 given data by means of vertical belt drive. So it is clear that belts are acting downward, force is acting, tension on tight side and slack side is downward. The diameter of belt pulley is 1 meter. The diameter of belt pulley is 1 meter apart. So I will have to draw here for sake of your understanding. So this is the pulley which is having, they have mentioned the diameter 1000 mm. So radius of course 500. Then what we'll have to do, of course, on this the load is acting vertically downward. As I told you, P1 tension on tight side, P2 tension on slack side, and self weight of respective pulley. Then they said the diameter of belt pulley is 1 meter apart, 1000 mm I have written, and pulley overhangs 150 mm beyond the center line of end bearing. Now it is very important to know where is end bearings are situated. So of course bearings are situated at end in most of the cases for the giving the rotation. So I'll draw the diagram for understanding that. Now here is your pulley structure, that is with respect to this, correct? And then I will have to draw the shaft, and then I will have to draw here bearings. Now what they say, again read, pulley overhangs 150 mm beyond center line of end bearing. So end bearing is this center line, and pulley overhangs, so this distance they have mentioned 150 mm. Okay. After that they have suggested the belt's tension act vertically downward. So while it is acting downward, we have shown P1, P2. The tension on tight side of the belt is 2.5 times slack side. So I will have to write here in given data P1 by P2 is equal to 2.5. They have given the shaft made up of steel, of course, ductile material, steel 40 C8. Its SYT yield strength is given 380 Newton per mm square, and factor of safety FOS we can say generally 2.5, and the mass of the pulley they have given M is equal to how much, 25 kg, correct, and determine the diameter of shaft, that is small d, which we have considered for the diameter, this diameter small d, correct. So as I told you, you will have to write the data carefully, read the statement and write down like this way. So I have developed the drawing also, so you can also do likewise, so that will understand very easily. So given data is over. Step number 1, I'll start with the step number 1. Step number 1 is to calculate the permissible stress. So I'll directly write tau max is equal to 0.5 times yield strength divided by factor of safety. Everything is known. So I'll just put the value like this, 0.5 into 380 divided by 2.5. Just try to calculate this answer. So it will become around 76 Newton per mm square. So this will be the first step that we have seen about the tau max. Now step number 2, calculate torque developed. So it means I'll directly write MT is equal to question mark. In exam you can write the torque developed in the shaft detail and in bracket empty. So I'll directly write, because I told you in this in design procedure lecture. So empty is equal to question mark. So I need to calculate. So I will have to write empty is equal to P is equal to 2 pi nt by 60. So that formulation I just converted into terms of the empty. So that is empty is equal to 2 pi n empty. Sorry, this is P is equal to divided by 60 into 10 raised to 6. This is kilowatt. So empty is equal to, that is P, which is in kilowatt, into 60 into 10 raised to 6 divided by 2 pi n. So everything is known. So we'll have to add very easily. So I will write P, how much? Given data 25, correct, into 60 into 10 raised to 6. This will be comes in numerator. At the denominator 2 pi and n, how much RPM they have given? 200. So just find out, you will get the value of empty here. So just calculate, and that value would be in Newton mm. So value is, to calculate the torque, it will be around, just tell me, it will around 1193662.07. So this will be the value directly coming for torque. Step number 2. Now we'll move toward the step number 3. So we'll have to write step number 3. What is step number 3? To calculate the tension on tight side as well as a slack side. So I'll write P1 and P2 question mark. So that we need to calculate. While doing this, now here, as I told you, we know the basic equation, that is empty is equal to P1 minus P2 into R, that is radius. Now here pulley is having 1000 mm diameter, so radius is 500 mm, and P1 P2 we don't know, but empty torque we know. So this value we know, we don't know this one, and we know this. So one unknown is there. So better way, we'll have to select any another condition given from the given data. So they have mentioned tension on tight side with respect to slack side ratio is 2.5. So I will have to take this. P1 by P2 is equal to 2.5. So broadly I can say P1 is equal to 2.5 times P2. So this value I have to put here, so that, see, this value I will have to put here, so that I'll get first P2. By putting the value in above equation, I'll get the P2. So I'll directly tell you the value of P2 is 1591.2 Newton. This will be the tension on slack side. Now tension on tight side we can calculate. So that is P1. How much? 2.5 times this answer. Correct? So it will be, I'll directly tell you, 3978.7 Newton. It is force, belt tensions. So P1, P2 we got the value very easily in step number 3. Now step number 4 is to calculate total load acting on a shaft. So total load, for that I told you, that is, which is equal to P1 plus P2 plus W. W is nothing but M into G. So one by one I put the value, and so you can just put the value. I will not write here. I'll directly write the answer. So here the total load acting on a system is 581.56 Newton. Correct? So this will be the total load acting. Now see, this I have considered P1 plus P2 plus total load at a center, self weight of pulley, and through which I'll get the total load is 581.15.6 Newton. So this will be your total load acting on a system. Now our next step is to calculate the bending moment. Step number 4. I will have to write step number 4. So calculate bending moment. I'll directly write MB is equal to question mark. Now bending moment means what? Force into perpendicular distance. So here force is total load P1 plus P2 plus W into perpendicular distance is very important. Now you see the structure. See, this is the pulley P1, P2, W, which is acting at here. See, here. So this will be the total load, which we can say P1 plus P2 plus W, total load acting on a structure. Now I need to calculate the bending moment. So bending moment force into perpendicular distance. Now they have given the distance 150 mm from end of the bearing to the pulley. So that is perpendicular distance. So my equation will be MB is equal to total is 5815.6. This will be the force into the distance is 150 mm. So through which I'll get the bending moment for the given case is 872.350.5. Around this much your value is for bending moment. Now we know the final equation, that is step number 5. Step number 5 is related with the tau max is equal to 16 by pi d cube square root of bending moment square plus torsional moment square. Now here in this we have calculated this bending moment, also we have calculated. We have also calculated the torsional moment MT. Now remaining is only D. So just put all the values over here and you will get the diameter, which is in mm. So just try to find out, and from my point of view the diameter will be 46 point something mm. So always remember, while designing the shaft we'll have to take a diameter in terms of 5. Why? Because it can be made for the safer side, and for manufacturing also it is better. So in your exam I'll write, if the answer is that 46.7 or this much, I will have to take up in terms of the 5, it will be 50 mm would be the answer, or 50 mm diameter shaft should sustain the load and maintain the pulley rotations clearly. So this is about the solution of the numerical related to the shaft design. I hope you understood. I just follow the steps. First step is, of course, we'll have to calculate the shear stress, that is permissible. Second step, torsional moment. Third step, belt tension. Fourth step, we'll have to calculate bending moment. Fifth step, we'll have to use that all the values in the final equation. We'll get the diameter, that will be your diameter of the shaft. Okay, I hope you understood this session. Thank you.